Welcome to Agentic AI World, Interview Prep Series. I'm your host, and today we're tackling Episode 13, Multi-Agent Systems and Orchestration. This is one of the hottest topics in AI engineering interviews right now, so let's break it down. What is a multi-agent system? A multi-agent system, or MAS, is an architecture where multiple AI agents, each with specialized roles, work together to complete complex tasks. Instead of one monolithic LLM trying to do everything, you decompose the problem into smaller subtasks and assign each to an agent that's optimized for it. Think of it like a well-run engineering team. You don't ask your database engineer to write front-end CSS, and you don't ask your UI dev to tune SQL queries. Same principle applies to agents. The core components. Every multi-agent system has a few fundamental pieces. First, the orchestrator. This is the coordinator. It receives the high-level goal, decomposes it into subtasks, routes work to the right agents, and assembles the final output. Think of this as the project manager. Second, the worker agents. These are specialists. You might have a research agent that searches the web, a coding agent that writes and executes Python, a summarization agent that condenses long documents, and a quality checking agent that validates outputs. Third, the memory layer. Agents need shared context. This could be short-term working memory using a scratchpad or shared state object, or long-term memory using a vector database for retrieval across sessions. Fourth, the tool registry. Agents need tools, web search, code interpreters, API callers, database query interfaces. A good MAS has a well-defined tool registry with clear interfaces. And finally, the communication protocol. Agents talk to each other. You need to decide, is this message passing via a queue, direct function calls, shared state? Each has different trade-offs on latency, reliability, and debuggability. Orchestration patterns. Interviewers love asking about orchestration patterns. Here are the 3 you should know cold. Pattern 1, sequential pipelines. Agent A completes its task, passes output to Agent B, which passes to Agent C. Simple, easy to debug, but no parallelism. Use this when each step genuinely depends on the previous one. Pattern 2, parallel fan-out. The orchestrator sends the same task or related subtasks to multiple agents simultaneously, then aggregates results. Much faster for independent subtasks. The tricky part is the aggregation logic. How do you combine results that might conflict? Pattern 3, hierarchical delegation. A top-level orchestrator spawns sub-orchestrators, each managing their own team of workers. This is how you scale complex workflows. The challenge is avoiding coordination overhead and circular dependencies. Real interview question. Design a multi-agent code review system. Let's say an interviewer asks, design an AI system to automatically review pull requests. Here's how you'd approach it. Start with decomposition. A code review involves multiple concerns: correctness, security vulnerabilities, performance, code style, and test coverage. These are independent enough to parallelize. So you'd have a static analysis agent that runs linters and checks types. A security agent focused on OWASP vulnerabilities, things like SQL injection, hard-coded secrets, insecure dependencies. A performance agent looking for N+1 queries, blocking I/O, memory leaks. A style agent checking naming conventions and documentation. And a test coverage agent verifying that new code has adequate tests. An orchestrator receives the PR diff, fans out to all 5 agents in parallel, collects their findings, deduplicates overlapping issues, ranks by severity, and synthesizes a final review comment. This is a strong answer because it shows you understand parallelism, specialization, and result aggregation. Failure modes and how to handle them. Multi-agent systems fail in interesting ways. Be ready to discuss these. Agent loops. Agent A delegates to B delegates back to A. Solution. Use a call stack or DAG representation to detect cycles. Context drift. As agents pass context through a chain, information gets lost or distorted. Solution. Use structured schemas for inter-agent communication, not raw natural language. Cost explosion. Each agent call costs tokens. With 10 agents, each making 5 LLM calls, you've got 50 API calls per request. Solution. Use smaller, cheaper models for routine tasks. Reserve GPT for class models for complex reasoning. Partial failures. One agent times out. Does the whole system fail? Solution. Designed for graceful degradation. Some reviews are better than none. Frameworks to know. You'll be asked about frameworks. The main ones are LangGraph from LangChain, which uses a graph-based state machine for agent workflows. AutoGen from Microsoft, optimized for multi-agent conversations where agents debate and refine answers. CrewAI, which uses a crew metaphor with roles and tasks. And OpenAI Swarm, a lightweight experimental framework for agent handoffs. You don't need to have used all of them, but you should know their core abstractions and trade-offs. Key interview tips. 1. Always start with the problem decomposition. Show you can break a complex problem into agent-sized subtasks. 2. Talk about communication and shared state explicitly. Many candidates forget this, and it shows a gap. 3. Mention observability. In production, you need to trace which agent said what, in what order, and why. Distributed tracing for agents is still an unsolved problem, and naming it shows senior-level thinking. 4. Discuss cost awareness. Multi-agent systems can be expensive. Show you've thought about model routing, using cheap models for simple tasks, expensive models only when needed. Quick summary. Multi-agent systems decompose complex tasks across specialized agents coordinated by an orchestrator. Key patterns are sequential, parallel fan-out, and hierarchical delegation. Core challenges are context management, failure handling, loop prevention, and cost control. Know at least one framework. LangGraph is a safe bet right now. That's episode 13 of the Agentic AI World Interview Prep Series. If this helped you, subscribe and hit the notification bell. We drop new episodes every week. Good luck in your interviews. You've got this.